Hello everyone, sorry I'm doing this recording at home, and this time around I'm going to teach you trigonometry. Hope you will see. Trigonometry is a paper 1, paper 2 topic, so please you have to pay extra attention. It's possible you can get everything concerning this topic. Tri means 3 and metry means measurement. So to be specific, in this topic we only deal with a shape which has got 3 sides and 3 angles, and that is a triangle. So before we look at the details of the topic trigonometry, let's study the types of triangles, because that is very important. Remember that in any type of a triangle given, the sum of their angles is always 180 degrees here. So it's always 180 degrees to all the types of triangles that we are going to discuss here, specifically 4 of them. The first one is called the right-angled triangle. But what are some of the properties of a right-angled triangle, and how would you know that this is a right-angled triangle? In a right-angled triangle, there is always a 90-degree symbol. Okay, it is only a 90 degree which has got a square symbol. Okay, any other type of triangle is represented in this way. Okay, but a right angle or a 90 degree has got a square symbol. That makes you to know that this is a right angle triangle. The other thing is one angle is 90 degree in a right angle triangle. Okay, so when you see a 90 degree angle in a triangle, just conclude to say that is a right angle triangle. We'll soon look at why this triangle is important in details. The next type of a triangle is called the isosceles triangle. The properties are, in an isosceles triangle, 2 angles are always equal and 2 sides are always equal. So to show and communicate to you mathematically, we use symbols. To show that 2 angles are equal, we can refer to that. And then to show that the 2 sides are equal, I can simply put this and that. If there is another pair of angles or sides which are equal, I can use 2 of them on both sides. That's the communication which is usually used in mathematics. The third type of a triangle is called equilateral triangle. From the name itself, equilateral. In here, all the 3 sides are equal, meaning we can simply say this side here, this side is equal to this side is equal to that. That's the way we write. Okay, and also all the angles are equal. Now remember we said the sum of angles is 180. So in an equilateral triangle, each angle is 60. Because if you say 60, 60, 60, or 60 times 3 gives us 180. So that is the property in an equilateral triangle. The fourth one is a scalene triangle. Now in a scalene triangle, all the 3 sides are not equal and all the 3 angles are not equal. To show that, we can simply say this side is not equal to this, is not equal to that. So to have these 2 different lines to show that they are not equal. Also for the angles, we can simply say this angle is not equal to this angle, is also not equal to this angle. So I can put 3 of them there. So this shows that the 3 sides are not equal and the 3 angles are not equal. So basically these are the major types of triangles that you need to take into consideration. We'll still come back to this and look at why they are very important. Now remember, in trigonometry we deal with calculations to do with the angles, sides, that is length and distance, shortest distance, area, solving trigonometric equations, as well as the graph for the sine and the cosine together with the tangent ratios. These 2 have just been introduced recently in the new syllabus, because we used to teach this in additional math. Your syllabus D used to end up to the area. So we'll consider everything here. This makes the entire trigonometry. Okay, so now let's get back to one type of a triangle which is very important, and this is a right angle triangle. A right angle triangle has got a symbol which is for a 90 degree. Now the sides have got names. The side which is opposite to 90 degree is called the hypotenuse, and it is the longest side. Whether they don't look longer than the other, what and what, consider that the one that will be always opposite to 90 degree is the hypotenuse, and it's the longest. Then the other two sides alternate depending on where the angle is. If the angle is here, then this will be opposite, then the remaining one will be adjacent. If the angle is here, then this one will be opposite, then the other one will be adjacent. Alright, so these two alternate, not this one. To deal with the calculation concerning right angle triangle, only two things are used, and that is SOHCAHTOA and Pythagoras Theorem. I repeat, SOHCAHTOA and Pythagoras Theorem is only used in this type of a triangle called right angle triangle. Okay, so now SOHCAHTOA solves both sides and angles, but Pythagoras only solves sides. Okay, so you need to take note of that. SOHCAHTOA solves for both angles and sides, but Pythagoras Theorem only solves the sides. Let's quickly look at the example. Example is given here. Here is a triangle here, and then they are asked to calculate x. You see where x is? We are calculating the length or the side here. I've been given two sides, which is 3 centimeters and 4 centimeters. I've been asked to calculate the third side. In here, I will not even think of SOHCAHTOA. Why? I've not been given any of the two remaining angles. Yes, I know that this is 90 degrees, but this side I'm not being given, and also the other one. So the only method or the only thing that can be used is the Pythagoras Theorem. How do we apply Pythagoras Theorem? If you are calculating for the longest side, that is hypotenuse, you have to add the squares of the other two sides. But if you are calculating for either opposite or adjacent, you need to subtract the squares of the other two sides. Here is an example. Okay, so here I've identified that I'm calculating the hypotenuse because it's the one which is opposite to the 90 degree angle. So since I'm calculating for the longest side, hypotenuse, I have to add the squares of the other two sides, meaning 4 squared plus 3 squared. 4 squared gives you 16 plus 3 squared gives you 9. The addition of the two gives you 25. And then since it is a square, you have to get rid of the square by introducing a square root on both sides. If you cancel the square and the square, and the square root of 25 gives you 5 centimeters. So meaning this side here is 5 centimeters. That is the application on the Pythagoras Theorem. Let's look at the application for the SOHCAHTOA. SOHCAHTOA, here is an example. Okay, the triangle is given here. Then I've been told to calculate angle R. Okay, and R is here. Remember I said SOHCAHTOA can solve angles as well as sides. So in this case here, we are told to calculate R. It's an angle. Remember, angles are represented by capital letters. Okay, this is angle P, angle Q, and angle R. If they are small letters, then just know that they are talking about sides. So if I want to put sides here, I'll say whether there is angle R, capital letter R, then the small letter R will be here. Capital letter P here, small letter will be here for the side. Capital letter Q here, small letter will be this side here. So Q will be here, P will be there, R will be there. Okay, so now the question is to calculate the angle here, which is angle R. So here again, since it is angle, I should not even think of Pythagoras Theorem, because Pythagoras Theorem only deals with the sides. So for SOHCAHTOA, the application of SOHCAHTOA, there are 3 ratios in here. There is this sine, there is cosine, and there is tangent as well, represented or abbreviated as tan. So now, sine means opposite over hypotenuse. Cosine means adjacent over hypotenuse. Tan means opposite over adjacent. Only one ratio can be used at once. So in this case here, I do not know which ratio to use. Is it sine, cosine, or tangent? The question itself here will tell me which ratio to use. Okay, so I want this angle here, so I have to know the sides from since it is a right angle triangle, it has got names, the sides have got names, so I have to know the sides which is given. So in this case, this side here is given, and remember we said this is the side which is opposite to 90 degrees, therefore this is it, our hypotenuse, h, there. Okay, the angle I'm calculating is here. Alright, the angle I'm calculating here is here, so meaning this side here is my opposite. The adjacent here is not given, so I'll go back to the ratio. So in here, I've only been given OH, which is it, OH. Then I'll come to SOHCAHTOA here. Which ratio has got OH? You agree with me that it is the sine ratio. So now I have identified that no, the one that I'm supposed to use here is the sine ratio. So I'll write it in this way. Sine angle, which is always an angle there. Sine angle is always opposite over hypotenuse. Then I have to put values in there. What is my opposite? My opposite is 8. I'll put the opposite there. My hypotenuse is 14. I'll put the 14 there. Then I can change this to decimal, which will give me this 0.5714. Okay, which you can round off. You'll see there are many digits after that. So, but as you are rounding it off, it must be 4 digits there. Okay, now to get the angle, you have to press shift on your calculator, depending on the type of the calculator that you have. So it can be shift, others can be second function. So when you press shift and then sign, it will give you this symbol here with a -1 on top. Then the number you want to punch, which is 0.5714, and then equals, it gives you this. This is how we solve. So it can even solve sides. The SOHCAHTOA can solve sides together with the angles, and this is how we go about it. For the meantime, I leave it there. I'll give you 2 questions. You have to try as soon as possible.